There are 100 billion galaxies in our universe. Milky Way is only one of them, so let's talk a little bit more about all of these other galaxies. Here's a picture of a galaxy collision. We'll talk a little bit more about that too. Some galaxies are spiral galaxies, like our Milky Way, but others are egg-shaped or completely irregular in appearance. Besides their shape, galaxies vary greatly in the amount of stars that are inside them, gas and dust content, and some are more active than others. Galaxies tend to cluster together, and these clusters appear to be separating from each other, cut up in our universe, which we know is expanding. The reasons for all of the diversity among all the galaxies in our universe is still a topic of ongoing research. You've probably already figured it out, but a galaxy is an immense and a relatively isolated cloud of hundreds of millions to hundreds of billions of stars. And there are also vast clouds of interstellar gas within them. That's just gas between individual stars. Within a galaxy, each star moves in its own orbit, guided by the gravity generated by other stars within the galaxy. Since galaxies are so far away from us, only a few can be seen without the aid of a telescope. The Andromeda Galaxy, which is the nearest galaxy to us, this is a picture of the Andromeda, and the Andromeda Galaxy, and two smaller galaxies called the Large and Small Magellanic Clouds. And I got to see the Large and Small Magellanic Clouds when I went on a trip to Chile. So you can only see the Large and Small Magellanic Clouds in the southern hemisphere. In the 18th century, Charles Messier cataloged several fuzzy objects to be avoided in comet searches, and many of these objects turned out to be galaxies. And for example, the Andromeda Galaxy, the nearest one to us, is called M31. It's the 31st entry into Messier's catalog of fuzzy objects. Then in the 19th century, Herschel and a few others systematically mapped the sky, creating what they call the New General Catalog, NGC, which includes many more galaxies. So the name of the galaxy, if you see the M in front of it, that means that that's the name from the Messier catalog. And if you see the NGC in front of it, that's the name from the New General Catalog. And so sometimes they have overlapping names. So M82 is NGC 3034. This is an image of the Andromeda Galaxy. The Andromeda Galaxy is the nearest galaxy to the Milky Way at 2.5 million light years away. It's the nearest one, but it's still 2.5 million light years. And it is found within the constellation of Andromeda, so that's how it got its name. The Andromeda Galaxy is about twice the diameter of the Milky Way and about 25% to 50% larger by mass, but it is a spiral galaxy similar to ours. Here's the Andromeda Galaxy in different wavelengths of light. This one on the right was one of the first photographs of the Andromeda Galaxy taken in 1887. And here's what the Andromeda looks like in the infrared and ultraviolet. Here are the Large and Small Magellanic Clouds. These are dwarf galaxies, or sometimes what we call satellite galaxies, around the Milky Way. They are orbiting our Milky Way. This is the Small Magellanic Cloud at 200,000 light years away, and the Large Magellanic Cloud over here at 160,000 light years away. Generally, these galaxies are considered to be irregular galaxies because they don't have a particularly well-defined shape. And again, you can only see them in the southern hemisphere. It's these two objects, the Large and Small Magellanic Clouds, that are distorting the Milky Way's outer disk to give it that warped shape like we talked about in the previous mini lecture. So let's talk about some different types of galaxies, the main galaxy types. By 1920, Edwin Hubble had demonstrated that galaxies could be divided up on the basis of their shape into 3 types and 2 subtypes. And so these are the 3 types of galaxies. Ignore what it says here, 4 groups. Really, there's 3 groups. We've got the spiral galaxies, the elliptical galaxies and the irregular galaxies. Here are a bunch of different properties for each of these galaxy types. But the thing that mainly I want to point out is that the majority of observed galaxies in our universe are of the spiral galaxy type. Spiral galaxies have arched spiral arms, and these spiral arms are locations of ongoing star formation, just like we see in the Milky Way. And these spiral galaxies are classified by letters A through C to distinguish how large the nucleus is and how wound up the arms are. Barred spiral galaxies are very similar to the spirals, except their arms originate from a bar at the center of the galaxy. And they are also broken up into 3 subgroups, sub A, sub B, sub C. So we've got and SB stands for the spiral bar. We've got the type A, type B, and type C. So in particular, the type C spiral barred galaxies are going to have a really long bar, and then they'll have pretty distinct arms that come off the ends of those bars. Elliptical galaxies appear to be just balls of stars. They don't have these beautiful sweeping arms. These galaxies generally have very little gas and dust and are mostly dominated by old red stars. And they're also given a demarcation to say how spherical versus how elliptical is the shape of the galaxy. So E0 elliptical galaxies are pretty much a sphere. E6 elliptical galaxies are going to be very long and stretched out, kind of like a cigar. And then we have irregular galaxies. They don't have arms, they aren't uniform in appearance. These galaxies generally have stars and gas clouds distributed in random patches. This slide shows the Hubble classification scheme a little bit more clearly for spiral galaxies and ellipticals. A spiral type A galaxy will have a very large bulge in the center, and its arms will be tightly wound around that bulge. And as we go from A to B to C to D, that bulge in the middle becomes smaller. And as we go from A to D, the arms become less tightly wound around the center. And then with ellipticals, an E0 type elliptical is pretty much a sphere. And then the further we get out, as we get down to E7, those elliptical galaxies are going to be much more stretched out, more like a cigar. This is what we call the Hubble tuning fork to help us even better classify galaxies in a graphical form. We've got the elliptical galaxies from E0 up to E7, and then we also have a kind of intermediate stage between ellipticals and the spirals here, where they're calling S0. And then the galaxies break off into 2 different types of spiral galaxies. We've got the barred spirals down here, and then we've got the regular spirals up here. Remember that the barred spirals have a long bar, long bright bar in their middle, and from the end of those you have spiral arms. Now, in the spiral classification, A-type spirals are going to have a larger nucleus, and the arms are going to be wound more tightly around that. And then as you get away from A and move toward D-type spirals, that nucleus becomes smaller, the bulge becomes smaller in the center of the galaxy, and those arms are going to be less tightly wound around the center of the galaxy. And then you have the irregulars left over. So I'm going to ask you to use the Hubble classification system and our Hubble tuning fork here to help you classify some galaxies as either being elliptical, spirals, or irregulars, and challenge yourself within the ellipticals and within the spirals if you can break them out into the barred spiral or not, and then if you can break them up into let's say if it's an elliptical, could you say it's an E0 or an E7 or somewhere in between? And then with the spirals, could you say that it's an A-type spiral or a C-type spiral or somewhere in between? And then we also have the irregulars. So I'm going to show you a set of galaxies And in the engagement check, you are going to tell me, is it elliptical, is it a spiral, or is it irregular? And if you want to challenge yourself, maybe you could kind of decide, is it within the ellipticals, is it somewhere around E0, E5, E7, so on? And within the spirals, is it a barred spiral? Is it more of an A-type spiral, or is it more of a C-type spiral? So here we have Galaxy A, NGC 1300. Galaxy B, Maffei 1. Galaxy C, the Whirlpool Galaxy. Galaxy D, NGC 2217. Galaxy E, NGC 1427A. Galaxy F, the Evil Eye Galaxy. Galaxy G, M87. This is the same galaxy that has the supermassive black hole in the center that recently we got a picture of. And within this galaxy, there's this jet of material streaming outward from that black hole in the center. And Galaxy H, NGC 2337.